Starting a rocket engine isn't like turning a key, it's a moment of orchestrated violence teetering on chaos. In that split second, decades of engineering, months of preparation, and the hopes of an entire team are put to the ultimate test. The ignition is the culmination of countless calculations and simulations, all converging in a single explosive instant. Elon Musk calls it a controlled explosion, and that's no exaggeration. The phrase captures both the raw power and the delicate balance required to harness it. Every launch is a reminder that, at its core, rocketry is about mastering forces that would otherwise be wildly destructive. You're unleashing immense energy in a tiny space, forcing super-chilled propellants and searing plasma to work together. The combustion chamber becomes a crucible, where liquid methane and oxygen meet and react in a flash of heat and light, creating a torrent of expanding gas that must be precisely directed. The goal? Channel that explosive force downward, generating the thrust to lift a skyscraper-sized rocket skyward. It's a feat that transforms violent energy into controlled motion, overcoming gravity's relentless pull. With an engine as advanced as Raptor, the challenge is magnified. The Raptor's full-flow staged combustion cycle pushes the limits of what's possible, demanding absolute precision from every component. It's a marvel of engineering, operating at pressures and temperatures that would destroy ordinary materials. The metals must withstand not just heat, but the relentless pounding of shock waves and vibration. The ignition sequence is a race against milliseconds. Cryogenic methane and oxygen must flood in, then ignite at the perfect instant. There's no room for hesitation or error, timing is everything, and the margin for mistake is razor thin. Too much propellant before ignition and you risk a catastrophic explosion. The engine can be torn apart before it even gets a chance to roar to life. Too little and the engine sputters or shakes itself apart. Unstable combustion can lead to vibrations so violent they rip through metal and electronics alike. Every startup walks a razor's edge between success and disaster. The tension in the control room is palpable as everyone waits to see if the engine will light cleanly or if disaster will strike. This is the art of starting a fire so powerful it can tear through steel, yet so precise it can push humanity toward the stars. It's a paradox, unleashing destruction to achieve creation. The Raptor engine is SpaceX's answer to the challenge of building a fully reusable rocket. Its design is meant to be fired, landed, and fired again, pushing the boundaries of what's possible in spaceflight. But its revolutionary design makes ignition the most perilous moment. Every test is a leap into the unknown, where innovation meets the unforgiving laws of physics. Taming this controlled explosion is the first, most critical step on the road to the cosmos. It's the moment when dreams of interplanetary travel either ignite or go up in smoke. It's the price of ambition, and the gateway to everything that follows. Each successful ignition is a testament to human ingenuity, and a promise that the stars are within reach. Imagine lighting 33 powerful matches at the same instant. The sheer intensity and coordination required are mind-boggling. That's the challenge of the Super Heavy booster, a marvel of modern engineering. Each Raptor engine is a controlled explosion, and all must ignite together in perfect harmony. The process starts with turbopumps spinning up to force cryogenic propellants into the combustion chambers. Timing is everything, and precision is key. All 33 engines must reach the right mixture and pressure within milliseconds to ensure a successful launch. If one engine fails or lags, it can throw the rocket off course or trigger a chain reaction of failures, jeopardizing the entire mission. The computers monitor thousands of data points, ready to abort if anything's off. The goal is clear. All engines roar to life as one, a breathtaking display of power and precision, showcasing human ingenuity. SpaceX has spent years perfecting this launch sequence, overcoming countless challenges. When it works, it's a symphony of fire, a testament to human perseverance, proof that chaos can be harnessed and controlled. It's the ultimate test of engineering discipline, pushing the boundaries of what's possible. At the heart of Raptor's power, and its extraordinary risk, is the full-flow staged combustion cycle, a cutting-edge approach that sets it apart from nearly every other rocket engine ever built. Unlike most engines, Raptor uses all of its propellants for thrust, ensuring that nothing is wasted. Every drop of methane and oxygen is put to work, maximizing efficiency and power output. Two powerful turbopumps, one dedicated to methane, the other to oxygen, each generate hot, high-pressure gas streams. These streams feed directly into the main combustion chamber, driving the engine to incredible levels of performance. This innovative design delivers not only higher efficiency and more thrust, but also allows Starship to carry heavier payloads much farther than traditional rockets, opening new possibilities for deep space missions. The use of cooler, less corrosive gases throughout the system means less wear and tear on engine parts, making rapid reuse and quick turnaround between flights a reality for the first time at this scale. But this technical elegance comes with immense complexity. The Raptor is essentially two engines in one, with a maze of intricate plumbing and valves to keep fuel and oxidizer separate until the precise moment of combustion. Ignition is doubly complicated. Two pre-burners must start in perfect sequence before the main chamber can ignite, demanding flawless timing and control from the engine systems. The result is a true masterpiece of engineering performance, but also a high-wire act of risk, where every component must work in harmony. Every ignition is a delicate dance, balancing superheated gases and cryogenic liquids, with temperatures and pressures that push the limits of modern materials and engineering. That's what makes Raptor not just revolutionary, but also one of the most challenging rocket engines ever developed, a bold leap forward in humanity's quest for the stars. In rocket science, milliseconds decide between flawless launch and disaster. A hard start, uncontrolled combustion, can destroy an engine in the blink of an eye. Too much oxygen before fuel, and the chamber melts from within. Too much fuel, and a pressure spike can rip the engine apart. On a booster with 33 engines, one failure can trigger a catastrophic chain reaction. These aren't just theoretical risks. SpaceX learned the hard way during early Raptor tests. Each failure taught engineers how precise the timing and mixture must be. They refined valve timing, pump speeds, and temperature controls to tame the first milliseconds of ignition. The lesson: mastering ignition is the key to making launches routine. Every successful start is a victory over chaos. The margin for error is razor thin, but with each test, the process becomes more reliable. To reliably ignite 33 engines, SpaceX reinvented the Raptor. Raptor 3 features a central fuel transfer tube, replacing complex external plumbing and reducing failure points. This single, robust tube delivers methane efficiently and strengthens the engine. Advanced cooling channels circulate super-chilled methane through the chamber walls, keeping metal safe and preheating the fuel for stable ignition. These innovations make ignition more predictable and controllable. The result? A lighter, cheaper, and more powerful engine, delivering 269 tons of thrust. Raptor 3 transforms the engine from a temperamental prototype into a dependable workhorse. More reliability means higher mission success rates. When all 33 engines ignite perfectly, it's a leap forward for Starship. Raptor 3 is a milestone in operational confidence. It's the engine that makes rapid, repeated spaceflight possible. SpaceX's philosophy breaks from aerospace tradition. Instead of building engines to be endlessly repaired, they design for reliability and rapid replacement. Raptor 3's integrated systems, like the central fuel tube, make it robust but harder to fix. That's intentional. It's better to have an engine that rarely fails, even if it's harder to repair. Engines are treated as line-replaceable units, swap them out fast like jet engines. Starbase is built to mass-produce Raptors, enabling quick turnarounds between flights. Advanced manufacturing, including 3D printing, makes this possible. The result: engines that are cheaper, faster to build, and more reliable. This shift is key to making rockets as reusable as airplanes. It's how rockets become vehicles, not artifacts. Reliability and rapid replacement unlock the future of spaceflight. Even as Raptor 3 proves itself, SpaceX is already developing Raptor 4. The goal: more power, greater reliability, and higher efficiency. Engineers are refining every detail: combustion, cooling, materials, using data from every test and flight. The aim is an engine that can fly dozens or hundreds of times with only routine checks. More efficient engines mean fewer launches for Mars missions, simplifying interplanetary logistics. Raptor 4 isn't just an upgrade, it's a critical enabler for deep space exploration. Each improvement brings the dream of Mars closer. It's the next step in making humanity a spacefaring species. The Raptor engine's story is about taming fire for exploration. Mastering ignition, especially across 33 engines, is the key to making Starship reliable. Every flawless launch proves that chaos can be controlled. Reliable ignition unlocks everything: bigger Starlink launches, in-space engine relights, and complex missions. In-space relight is essential for deorbit burns, orbital maneuvers, and Mars journeys. Each successful test brings us closer to the Moon and Mars. The journey isn't a single launch, but a series of orchestrated steps, all dependent on reliable ignition. Taming fire on the pad is the prerequisite for taming it in the void. Perfecting this controlled explosion is about building the transportation system for our future. With every challenge overcome, SpaceX forges the key to the final frontier.